Hi, I'm Stephanie and I'm here to teach you about mirrors. Let's get started. Our terms. We have a virtual image, which appear to originate from behind the mirror, and it's basically your reflection in the mirror. Then we have real images, which occur when light rays converge, and that's on the side of the object. So it would be basically having your image right next to you instead of on the mirror. And then inverted images are upside down images, just flipped, like if you were looking on the one side of a spoon. We have our focal point, which is the single point curved mirrors are reflected through, and the center of curvature, which is double the focal point. So to get focal point, we would use F equals center of curvature divided by 2. Types of mirrors, bro. We have plane mirrors, which the image appears exactly the same distance away as the object. We have curved mirrors, concave, also known as converging mirrors, bends inward. We'll see those next slide. And convex mirrors, also known as diverging, bends out. We'll see that in the slide after. Concave mirrors. These produce virtual and real images. The focal length depends on the radius of the curvature. So, the radius of the curvature, we'll know that from the actual mirror, and then we use that to find the focal. The focal length is always positive, and, ooh, geez, am I moving that? Oops, sorry. Technical difficulties. It has three rays. Ray 1 is parallel and then goes through the focal point. Ray 2 goes through the focal point and then goes parallel. Now, ray 3 you don't always have to use, but if you can use it, you go through the center of curvature all the way down, and it reflects back upon itself. Where these converge is where you will find your image. Like this one right here is a real inverse image. Convex, also known as diverging. They diverge parallel light rays away from the mirror, and light rays seem to focus behind the mirror. This only produces virtual images and has a negative focal point, such as why there is focal points on both sides and also a center of curvature on both sides. It has same amount of rays but different. This time, ray 1 is parallel as before, and then it reflects so that it goes through the focal point on the other side. But it also has to keep going through on this side. Ray 2 starts down towards the focal point, and then reflects parallel. So this is the actual line parallel. This is just the direction it would have been headed. Ray 3 heads straight for the center of curvature and then reflects back upon itself. So 3 is right there. First, we have our mirror equation, the first of our equations besides the focal length one. The object distance, SO, we have our SI, which is our image distance. So we have our object distance added to our image distance. Both of them, the O below 1 will equal our focal length, distance from the mirror to F point. We assume the radii of curvature is much larger than the mirror itself. Now we move on to our magnification equation, where m equals magnification, hi is the image height over the object height, absolute value, which also equals the image distance over the object distance, absolute value.